In this video, I'm going to do an example problem where I show you how to write an equation of a line that goes through a certain point and that's perpendicular to another line. Okay, so here's a question. It asks us to write an equation for a line that passes through a point and is perpendicular to another line. So they want the equation in slope-intercept form. So remember that's y equals mx plus b, and b is the y-intercept. So we need an equation that passes through 3, -2, and is perpendicular to y minus 3 equals a third times x minus 5. Okay. The fact that we know that our line should be perpendicular to this line, what that tells us to do is to find the slope of this line and then find a perpendicular slope. And then this will have a slope once we do that, and we'll have a point. So it will be useful for us to do our equation in slope-point form first, and then to change it into slope-intercept form. Okay, if we just make a little sketch of what this should look like. Our point 3, -2. So this will just be a sketch. It's not any kind of necessarily really accurate drawing. 3, -2 could be here. And now let's look at the slope. We could, on our sketch, we could graph this line, so we know the slope and we know a point from this value, but we actually don't really need to. We could just take the slope from this and then use that to graph our line. So the given line just to organize what we know about this is slope-point form, so it's y minus y1 equals m times x minus x1. So our slope is right here. The given line has slope 1/3. So our line slope, because our line is perpendicular to this, our slope will be the negative reciprocal. So we flip it upside down to get the reciprocal, that's 3/1, or 3, and then we change the sign, so it'll be -3. So our line is going to have slope of -3, and it's going to go through this point A over here. So to draw a little sketch, we'll go up 3 and then back 1. 3 and back 1, so it'll be pretty steep. Maybe about like this. Okay. So we'll use this to double check our final answer. Okay. So let's use slope point form, because now we know our slope and we know a point. So we've got y minus y1, so y minus, and then it's really worth it to spend a little extra time identifying your x and y here. We've got the point 3, -2, so that's x1, y1. And it's worth it because of this. When we substitute it in the equation it'll have the opposite sign, and it also happens to be in the opposite order, so it's just really easy to get mixed up. So y subtract y1 is y subtract -2. So I'm going to write that right away as y plus 2 equals, and then m, so that our line has slope -3, times x, subtract x1, so that's x minus 3. Okay, so if the question didn't specify that they wanted the equation in slope-intercept form, we'd actually be done right here. But because they do, we'll just switch to slope-intercept form. So we'll just simplify the right-hand side, so -3 times x is -3x. -3 times -3 is +9, y plus 2. And then we need to isolate y, so we've got y plus 2, so we'll subtract 2 from both sides. And we have y equals -3x plus 7. Okay, so that should be our answer. Let's just go back to our sketch and make sure that that looks reasonable. So this line has a slope of -3. And this looks like a slope of -3. It's definitely negative because it's going this way. And it's pretty steep. It looks like it goes up 3/1. And then a y-intercept of 7. Let's write the points. The coordinates at this point. 3, -2. So if this is down 2, this looks like this, where they meet about here. That may well be up 7. That looks totally reasonable. So these sketches are obviously a bit approximate. It's hard to tell if that's really 7 or if it's 6 or 5 or 10. But if we had a y-intercept of -7, we'd know that that was definitely wrong. Or if we had a y-intercept of -1 or anything really close to the x-axis or in the negatives, we know that was wrong. But 7, that looks right. Okay, so we've got our answer. It looks totally reasonable. Let's just do a quick little review of what we did. We wanted an equation for a line that goes through a certain point and perpendicular to this line. It turns out that the only information about the given line that we need is the slope, the 1/3. So we used that. We took the negative reciprocal slope to get our slope. And then using that slope and the point A that the line goes through, we substituted those into slope point form and then simplified and rearranged that to get slope intercept form. Okay, good luck.